Hello friends, today we are going to discuss roots of equation. In that we will discuss bisection method. Myself Amit Bagure, working as an assistant professor in Kekewak Institute of Engineering Education and Research, Nasik. Years ago we have learned to use this quadratic formula to find the values of x such that these functions become 0. That is called as direct method. The values calculated with this formula are called roots of the equation. Sometimes roots of equation called as zeros of the equation. There are many other functions for which a root cannot be determined so easily. For some cases, root could be obtained by direct methods by using this formula, although there were equations that could be solved directly, there were many more that could not. In such instances, the only alternative is to use approximate solution techniques, that is nothing but the bisection methods. There is another method for estimating the root of the equation is to make a plot of the function and observe where it crosses to the x-axis. This function where it crosses to the x-axis, that is the root of this equation. It means at this point these functions become 0. That is called as roots of the equation. Sometimes it is called as zero equation. For today's video, our learning objective is, first of all, we will discuss the bracketing methods used for calculating the roots of the equation. In that we will discuss the bisection. So at the end of this lecture you should be able to follow the algorithm of the bisection method for solving a nonlinear equation. You should be able to use the bisection method to solve examples of finding roots of nonlinear equations, and you should be able to write the advantages and disadvantages of the bisection method. Now we will start. What are the ways to find the root of the equation? The one is bracketing method and the other one is open methods. Bracketing methods, in that we will discuss the bisection method in brief. In open methods there is a Newton-Raphson method and one is successive approximation method. It is also called as one-point iteration method. So in brief, now we will discuss bracketing methods, why it is called as bracketing methods, that we will discuss now. So bracketing methods always start with an interval. This is very important. Bracketing methods always start with an interval. So it means when you are plotting the function on the graph, that is the graphical method, so this function crosses the x-axis at one point on positive side and minus pi on the negative side. It means this function is having two roots. One is 1 and another one is minus pi. So if you want to start with the bracketing method, so you have to always start with the initial guesses. So initial guesses should be between the actual answer. It means you can start with 0 and 3. That is the interval you can start. Someone can start from 0 and minus 6. So suppose one is starting from 0 and 3, so he will get the answer 1. Suppose another person is starting from 0 and minus 6, he will get the answer minus 5. That is the bracketing methods. Now we will discuss bisection method, which comes under the bracketing method. Bisection method is the, you can see in this small animation, bisection, it means bisects. So all of you know bisects, it means to divide something into two equal parts. That is also called as binary chopping. Okay, and it's the simplest bracketing method. The another one, regular falsi, which also comes under the bracketing method, but bisection is a simple one. It is also called as binary chopping or Bolzano's method. So what is called binary chopping? Because we are dividing the interval into half. That's why it is called as binary chopping. It is based on two initial guesses. That bracket is the root. because it comes under the bracketing method. This is a very important thing which you have to remember. It starts always with the two initial guesses, because open method starts with only one initial guess. Then two initial guesses, one you can call it lower value, that is xl, and one you can call it as upper value, that is xu. Now the procedure starts by finding the interval xl and xu. You already found the interval where the solution exists. Then now suppose you are plotting this function and your actual answer lies here at this black spot. Okay, this is your actual answer. Then your guesses, that is xl and xu, it should be one on the right side and one on the left side of this final root. If not, your answer may diverge. Okay. Now suppose you are having two guesses now, xl and xu. Okay, which brackets this root. Now suppose this condition is satisfied, f of xl into f of xu, which is less than 0. It means for this function at least one root exists. I repeat, suppose you are taking two guesses xl and xu and you are finding the functions at this xl and x value, and you are taking the multiplication value. If this value is less than 0, it means your function, okay, that whatever guesses you are guessing, it is having minimum one root. Okay. Now for next iteration we are using the binary chopping. Here you can see, now this is your final root, so you can take xl on left side, xu on the right side. Then you can use binary chopping method. It's very simple. You can just write xl plus xu divided by 2, so we will get this option at this. That's why we can replace xu by the next xu, because again this xl and xu for next iteration, your root, it should be between these two ranges, xl and xu. Like that we can proceed and we will reach to the final root of the function. It is bisection method is, suppose your initial guesses are correct, it is always converge. But disadvantage, you can say bisection methods converges but very slowly. Now we will discuss how to find root of the equation for any function by using bisection method. This is the algorithm we will discuss in brief. For the continuous function of one variable, function of x equal to 0. Here one thing important, if you are having more than two variables, you cannot make the use of these methods. So for finding the root of the equation by bisection method, only one variable should be there in your function. Now in step 1, you have to choose the guesses, that is lower guess xl and the upper guess xu, that brackets the root. It is very important. You have to guess the value which brackets the root. Okay. So suppose you are taking the two guesses and you have to check it that guesses are correct or not. So that guesses you can check by using this function, this formula. If the product of these two functions, f of xl into f of xu, is less than 0, then you can say your initial guesses are correct. It means at this xl value you can find out the function of xl, and for this xu value you can find out the function, that is f of xu. It means the function out of these two, f of xl or f of x2, out of these two functions, one should be positive and one should be negative. Then we can say our initial guesses are correct. At the first step, always have to check whether initial guesses are correct or not. Now in next step, you have to find the root of the equations now by using bisection method. Bisection, it means you have to bisect the line. That's why we are using simple formula for bisection method, that is xm. I use the notation xm. It's very simple. xl plus xu divided by 2. So why we are using 2? Because we are using bisection. Because this, so you will get the next root which is in between the xl and xu, that is xm. Okay, that is the second step. Then the third step, now you have to check the following condition. If f of xl into f of xm, that is you have calculated the new root, if it is more than 0, okay, suppose f of xl into f of xm is more than 0, then the root is lies between xm and xu. Okay, then the root, suppose we are having two values xl and xu, so by using second step you will get xm value xl plus xu divided by 2. Now for the next step, if you have to check it, function of xl into function of xm, if it is more than 0, then you can say xl becomes xm, so this value will be replaced by xl and xu remains xu. Okay, because your root is lies between xm and xu, that's why. Now suppose these things are not happening. Okay, suppose function of x1 into function of xm is less than 0, then what is going to happen? These things will be reversed. At that time xl becomes xl and xm becomes xu. These things happens when function of xl into function of xm is less than 0. Okay, these are very important steps, because in next iteration you have to always change the guesses. If function of xl into function of xm is more than 0, then a root is xm and stop the algorithm if this is true. Now this is your third step. In fourth step, you have to find the new estimate of the root by using the same formula of bisection. This formula is called as bisection formula. Then you can find the absolute relative approximate error, which can be used for when you are solving the numerical for accuracy best. So accuracy is given, you can find out xm new minus xm old divided by xm new into 100. That is, by using this formula you will get approximate or absolute relative approximate error. Now there are the fourth step you have to use for solving the numerical on bisection method. Now, so where you have to stop the iterations? Now there are two things, there are two approaches, or for numericals there are two methods. One is iteration based and one is accuracy based. For iteration based, you can stop after, suppose they are saying do up to 10 number of iterations, so after 10 iterations you can stop and you can write your final answer. But sometimes they will give you correct your answer up to 3 decimal places, up to 4 decimal places. At that time you have to use the accuracy based approach. It means you have to always check this error, absolute relative approximate error. If it is less than 0, you can stop the algorithm. If no, you can repeat the steps from 2 up to 4. Okay, so you can compare the absolute relative error, which is the given one, with the pre-specified error tolerance. Okay, if it is yes, go to step 2 using new upper and lower guesses. If it is no, you can stop the algorithm. It is mostly used for accuracy based approach. Now we will discuss one numerical, how to solve or how to find the root of the equation by using bisection method. For that we will take this example. Find root of the equation or function x cube minus 4x minus 8.95 using bisection method. We can assume initial guesses 2 and 3, and this numerical is based on iteration technique. That's why they are saying assume eight number of iterations. For such type of numericals, first of all, write down the given data. We can write first of all the given function in terms of x, that is f of x equal to x cube minus 4x minus 8.95. With initial guesses, we can assume x1 equal to 2. Second initial guess, we can assume x2 equal to 3. If initial guesses are not given, you can assume any value whatever you want. Then next input data is number of iterations. We can denote it by letter n equal to 8. Now in step 1, now we have to check whether initial guesses are right or wrong. Suppose initial guesses are given, most of the times they are right. If you are assuming your initial guesses, then you have to always check whether it is right or wrong. Okay, that is the first step in such type of numericals. So how to check whether initial guesses are right or wrong? Already we have discussed in algorithm how to check our initial guesses are right or wrong. It means whether the final root of this equation lies in between the two initial guesses. If not, you can change your initial guesses. So for that we can use this formula, the function of x1 into function of x2, it should be less than 0. If these things are happen, then we can say our initial guesses are right. It means you can put these two value in x and find out the value of function of x1. Next you can put this value of 3 in the given function and you will get the next value. If the product of these two functions is less than 0, then we can proceed. If not, we can change the initial guesses again. Okay, so first of all, if you are using initial guess x1, you will get the answer of minus 8.95, which is the negative value, and by using second initial guess, we will get the value 6.05. that is the positive one. If you are making the product of these two values, so obviously we will get the value which is less than 0. Then we can say our initial guesses are correct. Okay, there is another way we can say, if function of x1 and function of x2 have opposite signs, one is negative, one is positive, then also we say initial guesses are correct. That is the first important step we have to follow. Always check whether initial guesses are right or wrong. In step 2, we can calculate the bisection, that is a midpoint, okay, of the two initial guesses. In step 2, we can also say we will start the iterations, because they have to make 8 number of iterations. So in iteration number 1, first of all find the root of the equation using bisection formula, which is already we have discussed, x3 equal to x1 plus x2 upon 2. So x1 is the first initial guess, x2 second initial guess. Bisection, that's why we are using 2 here, that you will get the new root, that is x3. So after putting the values in the given formula, you will get new root is 2.5. okay, so x3 is 2.5. Later on you have to find the function of x3, then you have to put 2.5 in the given function and find out the value. Okay, so you will get the value minus 3.25, which is a negative one. Now in step 4, we have to check now how to replace the guesses. That is a very important step and little bit complicated. Which value x1 is replaced by x3 or x2 is replaced by x3, you have to check it. Now there are some simple techniques. One is, if function of x1 into function of x3, it is more than 0, okay, then the root lies between x3 and x2. Okay, then we can write x1 equal to x3 or and x2 equal to x2. It means there is no change in x2, only x1 is replaced by the x3. If these things are not happen, else we can write x2 equal to x3 and x1 becomes x1. There is no change in x1. Okay, this is one way to replace the guesses or replace the guesses for next iteration. There is a simple technique. Okay, these things, suppose you are not getting how to use this technique, because this is very useful when you are writing the flow charts. At that time you should know if else technique. For calculation purpose these things also work. Is another one. Now suppose function of x1 is negative and function of x2 is positive. This already we have got in previous slide. Function of x1 is negative and function of x2 is positive, and function of x3 I will get negative. Okay, so we can say function of x1 is negative, function of x3 is negative. At that time we can write x1 is replaced by x3 and x2 will remain same. Now suppose you are having f of x3 is positive, then we can write x2 equal to x3 and x1 equal to x1 to change the initial guesses for next iteration. So up to this first iteration is over. Now for iteration number 2 we can make the use of same functions. Function of x1 already we have calculated, that is minus 3.25, which becomes a function of x1 for next iteration. Same for x2 is 3. For next iteration function of x2 becomes 6.05, which is previously calculated. Now for iteration number 2, so for other iterations we can put in tabular form. There is no need to show each and every iterations, okay, numerically. So later on we can put in tabular form. So I will show you now how to write the bisection table. So first of all x1 is given, so you can write 2 here, which is given data. The second also is given, that is 3. So first of all you can write 2 and 3, that is the first step we have followed. Then by using these 2 and 3 we can calculate the midpoint, that is 2 plus 3 divided by 2, so we will get 2.5. Okay, then we can calculate the function of x2. So function of x2 you will get minus 8.95. So solve, okay, or how to write this table within 2 to 3 minutes, that I will show you on calculator now. So how to write the equation in calculator 991 ES, so I will show you here. So function of x1 is, function of x is given in the previous slide. You can write, you can say here x cube minus 4x minus 8.95. So in tabular form, first of all these things are already given, 2, 3, you will get 2.5. So how you will get function of x1 on calculator? So we can write here alpha shift x cube. So we can write here alpha x, so x cube. Then you can write minus, next you can write here minus 4 alpha x minus 8.95. Then you can just say calculate. So he will ask you what is the value of x. So value of x is 2. We can write here 2 and say equal to. So the function of x is minus 8.95 for 2. So you will get here minus 8.95. Similarly, for 3 we can again say equal to, so I will ask what is the value of x, so you can say 3 equal to, so for 3 function of x2 is 6.05, so we'll get value 6.05. Similarly, for 2.5 again you can say equal to, for next is 2.5, I will get the answer, that is minus 3.325. okay, so you will get here minus 3.325. so by using the calculator you will get all these values in first iteration. In second iteration, now how to replace the gases? Now here check it, a function of x1 is negative. Now you have to check it which function is negative. So function of x2 is positive, function of x3 is negative. Okay, suppose function of x3 is negative, then x1 value will be replaced by x3. That's why here you can write 2.5, because function of x1 and function of x3 both are negative. So we can write 2.5, that is the new x1 for the second iteration. For 2.5, what is the function of x2? That's already we have calculated, that is minus 3.3250. we can copy from this location to this location, that is minus 3.3250, and there is no change in the xu, that's why we can write here similar value x3, x2 is 3 and function of x2 is 6.0. Then for calculating x3, again we can make the use of bisection formula, that is 2.5 plus 3 divided by 2, so we will get 2.75. So for this 2.75, what is the function value? At that time again we can make the use of calculator, just say equal to, so what is the value of x? So I want to calculate the function for 2.75 value, say equal to, that is 0.8468 for x3 value, that's why here 0.8469, so I am making the round off here, 0.8469. so can you please tell me in next iteration what is the changes? So which value is replaced by which value? So I will stop here for fraction of seconds and then we will continue. We have to check it here. Function of x3 is positive, so which function is positive? Function of x1 is negative, function of x2 is positive, so function of x2 and function of x3 is positive. For that, now we can write x3 becomes new x2. It means what is the new value of x2? That is 2.75. So 2.5, which is remain 2.5, function of 2.5 which already we have calculated, so we can again write minus 3.3250. x2 now is replaced by new x2, which is nothing but 2.75, because f of x2 is positive, f of x3 is also positive. For 2.75, function of is 0.8469, we can write here. Now for x3 we can calculate by using 2.5 plus 2.75 divided by 2, so we will get 2.625. Again for 2.625, what is the function value? We can make the use of again calculator, say equal to, what is the value of x? That is 2.625. the function value is 0.0013, okay, minus 0.0013, okay, that is minus 1.3621. you will get the value. Again I will check it on calculator. It is 10 raised to 3. It means we will get minus 1.362. So we get minus 1.362. Okay. Now for next iteration, what is the replacement? Again you can check. Function of x1 is negative, function of x3 is negative. Okay, that's why this 2.5 is replaced by 2.62. For next iteration, 2.625, that is the new value of x1. We can write first of all the same value is 2.70. There is no change in 2.75, so we can copy it in the next row. The function of the same 2.75. Instead of 2.5, we can write 2.625, and for the function of 2.625 is minus 1.3621. For calculating the value of x3, we can make the use of bisection formula. Then we will get x3 value is 2.6875. That function is already saved in the calculator. Just what is the value of the function for 2.6875? So value of x is 2.6875. So function value is 0.91. So you can write minus 0.2891. For fifth iteration, again you have to check what is the new value of x1 and what is the new value of x2. So function of x3 is negative, function of x1 is also negative. So 2.625 for fifth iteration, the new value of x1 is 2.6875. So we can again copy 2.75 as it is, because there is no change in value of x2 and function of x2. So we can copy it in the next row, and 2.6875, that is the new value of x1. Function of x1 is 0.2891. We have copied it from function of x3, and new value of x3 we can calculate again by bisection method. That is 2.6875 plus 2.75, that is 2.7187, 0.27. Now for sixth iteration, can you please tell me what is the replacement? Function of x3 is positive, function of x2 is positive. So we can copy same values. There is no change in x1, no change in function of x1. Now x2 is replaced by x3. So new x2 is 2.7187 and function of x3 is 0.27. Similarly, we can calculate x3, function of x3, and we can make all these things up to 8th iteration, because they have said make 8 number of iterations. And finally, the final answer for this question is 2.7148. That is the final root of the function after 8th iteration. This is your final answer, 2.7148. So thank you for watching my video on bisection method. So at the end, what are the advantages of the bisection method? So bisection methods always converging. Okay, and what is the drawback? The bisection method is always converging, but it's very slowly. That's why it is quite difficult to extend the use of bisection method for system of equations. So I will stop here. Thank you.